All right, guys, welcome back. We're into lesson two, chapter 8, lesson 2, function rules. We're going to be talking about this. Let's go ahead and get circled up while I'm thinking of it. We have 1 to 14 here. Just like yesterday's video, it's going to be longer because the lessons are getting more difficult. And I hope you're completing your work. So we have up to 14. Okay. And then we're going to jump to 18 through 27. Actually, let's just do 18 to 25. That way we'll keep it right here. It's quite a bit of work. You're absolutely going to need your calculator. So, um, anyway, let's get rolling. Okay, let's go ahead and there's a lot of vocabulary in this chapter, so we need to talk about it. All right. A sequence is a list of numbers in a specific order. Each number in the list is called a term. So if we went down here to this, these are called terms. They're in a specific order. What type of order? Well, there's two types. One type of order is called an arithmetic sequence, and this can be found by adding the same number consistently over and over and over. A geometric sequence is when you find it by multiplying. So geometric multiplying, arithmetic adding sequence. And that's all they want here. So arithmetic, we're going to add. Geometric, we're going to multiply. Okay? So that's important that we're squared away with that. All right, go ahead and flip it to the guided practice, page 590, and let's take a peek at it. And go from there. Okay, describe the relationship between the terms and the sequence. And these are the terms, the numbers 13, 26, 52, 104. Write the next three terms in the sequence. Okay, well, if you looked at this and you kind of saw this, this would be a geometric sequence, okay? Because 13 times 2 is 26. 26 times 2 is 52. And if you were unsure, you would grab your calculator and just take this number. And the first thing I would do is divide it. 52 divided by 26, and you'll see it's 2. Or 26 divided by 13, and it's consistently 2. So to scale it back up, we're multiplying it by 2. So the next three numbers in the sequence, all right, so we're going to multiply by 2. 52 times 2, okay. Oh, I didn't see that 104 there, did I? So it's 52 times 2 is 104. So we have 104. The next three would be 104 times 2 is 208. And all we're doing is doubling these, right? 208 doubled is 416. Again, you could use your calculator if you needed. And this times 2 is 832. Okay? So these are the next three numbers in the sequence. These are the next three terms, geometric because we're multiplying it by 2. Okay. Use words to describe the value of each term as a function of its position. Then find the value of the 15th term in the sequence. So when we look at this, okay, we have to kind of see what is going on here. What is the rule? All right. So how are we getting, all right, from the position to the value of term? That's what they're talking about. Position, right? This, how are they getting from there to there? Okay. So we're going to multiply, it looks like to me, because 1 times 2 is 2. 2 times 4 is 2 times 2 is 4. The third, 2 times 3 is 6. So if we were to write a function rule, all right, we're multiplying it by 2, we would write it by 2n. 2 times a number will give us any one of these. So 2 times any number of the position. So 2 times 4 is 8. I don't want that one. I want the 15th. So they're asking us, what's 2 times 15? And that would be 30. 30 would be the 15th number in the sequence. So if I carried this out to 5, 6, the bottom number would end up being 30. Okay, and we figured that out by this function rule. So now we're starting to figure it out. How are we getting from X to Y? All right, and that's important that we're able to do that. The table at the right shows the fee for overdue books at a library based on the number of weeks the book is overdue. All right, so 1 week you pay 3, 2 weeks you pay 5, 3 weeks you pay 7. Write a function rule here. All right, so looks like we have some problems here. So when we look at a problem like this, all right, we have to figure out what is the function rule. So, to me, the first thing I do is I see plus 2, plus 2, plus 2, all right, and so on. So when I see this, and from here to here is what? Plus 2? Plus 3, plus 4. So you see it's not just a consistent rule. So we're going to have a two-step rule. When I do this, this generally helps me find the number I'm going to multiply it by. So what am I multiplying? X. So it's going to be 2x, 2 times this, and then let's see what that does. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. So it looks like that's the rule. We have a two-step rule. 2 times 4 is 8, plus 1 is 9. Right? So this, by finding this number, I multiplied it by my x, and then just through trial and error, I found that I'm adding 1 to it. So that is a more difficult, more advanced two-step rule. Let's continue on and get into the homework here. Okay? All right. Number 1. And we'll bounce down through here a little bit. Let me see if I got you on here. Let me grab a little drink of coffee here. Use words and symbols to describe the value of each term as a function to its position. Then find the value of the 12th term. Okay, so when we have a function table, how are we getting from x to y, x to y, x to y, right? How are we getting from here to here? Well, 12 minus 3 is 9, so I'm adding 9. 13 minus 4 is, 9. I'm adding 9. It looks like to me the rule is plus 9. What plus 9? Any number plus 9 will give me the bottom number, the value of the term. They want the 12th term, so 12 plus 9 is 21. 21 is the 12th term. So if I carried these positions out to 12, the bottom number would be 21. Let's try that again. Okay, so this one's a little bit different. All right, this would be plus 22. Plus 22 is 25. It's not adding. So what I would do now is I would grab my calculator and I would see if that could help me. I would take 24 and 24 and divide it by 2, and I get, of course, 12. And then guess what I'm going to do? I'm going to try 36 divided by 3, and I get 12. And I'm going to try the next one, 48 divided by 4, and of course I'm going to get 12. So that tells us to get from here to here is times 12, times 12, times 12. So the rule is 12n. 12 times any number will give us the value of the term. We don't want any number, we want the 12th term. So 12 times 12 is 144. So I hope that made sense. Okay. All right, we are rolling on. Number 3, describe the relationship between the terms in the sequence 6, 18, 54, and so on. All right, then write the next 3 terms. Well, sometimes you can look at this and kind of see it. Well, I know 6 times 3 is 18. What's 18 times 3? And I find out that that's 54. What's 54 times 3? And I find out, 54 times 3, and I find out that that's 162. So the rule is what? Multiply the previous number by 3, or times 3, right? So 162 times 3 is 486. That's the next number. The next number after that, 486 times 3, is 1458, right? And then finally, that times 3 is 4,374. That's our rule, multiplying by 3. Now, we could define this. This would be a geometric sequence because we're multiplying it by 3. Okay? Okay, let's continue on. We'll do 4, 5, and 8. Okay? The table shows the amount it costs to rock climb at an indoor rock climbing facility. Based on the number of hours, what is the rule to find the amount charged to rock climb for X hours? So 1 hour is 13, 2 hours is 21, 3 hours is, we got some problems here because 1 times 13 is 13, but 2 times 13 is 26. So it's not a one-step rule. So when I don't have a one-step rule, I find the difference of these two numbers. Okay, so watch how we do this. 21 minus 13 is 8. 8. So we're adding 8, right? Plus 8. So we know that that's going to be one of our factors. 8 times x. Let's start there. That gives us what to multiply it by. Why am I using x? Because x is the time. 8 times 1 is 8. Okay. Plus 5 is 13. 2 times 8 is 16 plus, it's working, 21. 3 times 8 is 24 plus 5. So it's 8x plus 5. That is our function rule. I got this second number through trial and error. Okay? Okay. Let's continue. Number 5. Determine how the next term in each sequence can be found. Then find the next two terms in the sequence. So these are going back to the geometric and the arithmetic sequences. All right, well, this one, not too bad. It looks like if I add what here? 4 times 4 is 16, but 16 times 4, I don't think that's going to work. That's 64, right? So, that's not 64. So let's try this. Add 12. What's 16 and 12? Add 12, add 12. So the rule is plus 12, and the next numbers are 52 and 64 because this plus 12 is this plus 12 is that. Okay? We better work backwards here in this sequence, right? So now we're missing a number in the middle. Okay. So this is going to have to be through trial and error. It is, yep. So what I would tell you, okay, is we need to figure out what the difference between these two numbers is, okay? All right, because we're starting at 30 and getting a smaller number. All right, so 19 minus 13 and a half, and I'm going to call that 0.5. So we get 5.5. So this is a difference, all right, of plus 5.5, right, or 5.5, let's call it, right? Now, let's see. If I add 5.5 to 19, let's see what happens. 5 and a half to 19, we end up with 24.5. Now, I need to check that to see if that's my missing number. And how I do that is I'm going to add 5.5 to that. And if I do, I should get that number. And you know what? I do, because that does equal 30. So my missing number is 24.5. So this is an example of an arithmetic sequence because we're adding 5.5. The missing number is 24.5. Okay, so pretty long video today. Keep pushing. Have a good day, guys.